Lesson number 17, Algebra, volume 3. Application number 65. Solve the system 2x at 6y equal 3. Line d1, x at 3 multiply y equal 2. Line d2. Determinant 2 equal to 6, 1, 3 equal 0, d1 equal to d3 0, rank is 1 for matrix 2, 6, 1, 3. The determinant matrix t1 2 characteristic equal 2, 3, 1, 2, 2, 1, 3, 2, term 3 equal 4 minus 3 d3 0 is the determinant of characteristic, determining whether feature is non-zero, the system is inconsistent and has no solution. 2x at 6y equals 0, line d1, x at 3y equal 2, line d2, divided first equation 2x at 3y equal 3 divided 2, x at 3y equal 2, multiply minus 1 first equation, minus 6 minus 3y equal minus 3 divided 2, x at 3y equal 2, result 2 equal minus 3 divided 2 impossible, and so here is inferred that the system has no solution. Now, case 1, ax at by at cd equal d is a plan, so x at y at 2z equal 1, plan P1. Plan P1 intersect OX. Equation x-axis is y equals 0, z equals 0. X at y to z equal 1, plan P1. Y equals 0, z equals 0, equation axis OX. Result x equal 1, point intersect equal A. Coordinate 1, 0, 0. Plan P1 intersect axis Y. Equation Y axis X. X equals 0, Z equals 0. X at Y at 2. Z equal 1, X equals 0, Z equals 0. Result Y equal 1, point intersect B, coordinate 0, 1, 0. Plan P1 intersect axis OZ. Equation Z axis is X equals 0, Y equals 0. Plan X at Y P1 at 2 Z equal 1, axis Z axis X equals 0, Y equals 0, 2Z equal 1, Z equal 1, 2, point intersect C, coordinate 0, 0, 1 divided 2. Plan P1, x equal 1 minus y minus 2z, y belong minus infinity infinite, hence the infinite solution of z belong minus infinity infinite, another infinity of solution. So x equal 1 minus y minus 2z, point variable belong plan P1, m x y z, admit double infinity of solution. The system is double undeterminate. I admit double infinity of solution. Figure for plan P1. A, B, C, point intersect axis OX, A. B, intersect axis Y. C, intersect axis OZ. Figure 5. Case 2. B, AX at BY at CZ equal D. Equation plan P1. AX at FY at GZ equal E. Plan equation plan P2. EFGE ABCD constant. X, Y, Z variable. Plan P1 intersect plan P2 right after the intersect. On the right is a simple infinite point. Matrix A, B, C, E, F, G is rank of matrix A is 2. Determinant 2 equal A, B, E, F equal AF minus B different 0, rank is 2. Plan P1, plan P2, intersect right D, line D. Figure 6. Case 3, A1x at B1y at C1z equal D1, A1, B1, C1, D1 constant, x, y, z variable. Equation plan P1. A22 multiply x at B2 multiply y at C2 multiply z equal D2 equation plan P2. A2 B2 C2 D2 constant x, y, z variable. Equation plan P2. When plan parallel and remain P1 or P2 equation A1x at P1y at C1z equal D1 x equal B1 divided A1 y minus C1 divided A1 z minus D1 divided A1 y belong minus infinite infinite and z belong minus infinite infinite. Admit a double infinity of solution is double undetermined. Figure 7. Case 4. A1x at A2y at A3z equal A4. Equation P1. B1x at B2y at B3z equal B4. Equation P2. C1x at C12 at C3z equal C4. Equation plan P3. A1, A2, A3, A4, B1, B2, B3, B4, C1, C2, C3, C4 constant, x, y, z variable. If the system is compatible, M0 x coordinate x0, y0, z0 admit uniquely uniquely determined. So 3 planes intersect of the point M0 coordinate x0, y0, z0, the system solution. Figure 8. Application number 66. Solve the system of equation 2x at y minus z equals 0. Equation plan P1 minus 3x at 5y at 3z equal 2. Equation plan P2. A to plane P1 at P2 intersect them right after D, and so the system support indefinite, admit an infinite simple solution. Determinant 2 equal to 1 minus 2, 5 equal 13 different 0, the mine and count and x and y. Multiply equation 1, 3, multiply equation second 2, result 6x at 3y equal 3 at 3 multiply z minus 6x at 10y equal 4 minus 6z minus 6x add 6x equal 0, result 13 multiply y equal 7 minus 3z, y equal 7 multiply 13 minus 3 divided 30 multiply z. 2x minus y equal 1 minus z minus 3x at 5 y equal 2 minus 3z, multiply first equation minus 5 minus 10x at minus 5 minus 5y equal minus 5 minus 5 multiply z minus 3x at 5y equal 2 minus 3z, result minus 3 minus 13x equal minus 3 minus 8z, multiply minus 1, 30x equal 3 at 8z. X equal 3 multiply t divided 13 at 8 divided 13 multiply z, y equal 7 multiply 13 minus 3 divided 13 multiply z. Z belong minus infinite infinite, admit an infinite simple solution. M coordinate x, y, z.